All right. Hi, guys. Today we are looking at a specific triangle problem that we call the altitude to hypotenuse problem. If you remember back from Math 1, an altitude is when we construct a line segment that is perpendicular to the opposite side of a triangle. So basically, we're taking a line and creating it from that right angle down to the opposite side, which will always be the hypotenuse of a right triangle. So the cool thing is when we do this, we're forming three triangles. So we have the whole diagram, we have the bigger triangle on the inside, and we have the smaller triangle on the inside. And a cool rule with all three is that they're actually all similar to each other. I'll post another video on why, but I'm trying to keep this one a little bit shorter and just look at some different examples. So the nice thing with all three of these triangles being similar is it allows for a lot of solving problems where we're finding different side lengths. So we're looking at example 2 in our book on page 96. So if you guys want to get there. So if you notice, we're looking for x, which is our side that is the altitude that we drew in. This is all a proportion game. So the basic gist of it is we always need two sides within a triangle in order to set up a proportion with our ratios. So if we're looking for x, hopefully we're seeing it's a part of this triangle on the left-hand side. I'm going to suggest we start by redrawing these triangles. Okay, so I'm going to redraw this one. So this bottom corner will be a right angle, and that's because we have the right angle right here. And I'm just going to label this side down here as 18 and this side over here as our x. We need two triangles if we're going to be setting two ratios equal to each other. So we need another triangle. Now you're probably thinking, do I use the whole diagram? Do I use this little guy? It comes down to which triangle do you have two sides for. Okay, so we have two sides for the little triangle. Okay, so we're going to use this guy. So I'm going to redraw that one. Notice there is a longer and a shorter side. Okay, so for this triangle we drew, the 18 was the longer side than our altitude going up and down. Okay, but for the smaller triangle, the longer side is the one going up and down. Okay, so I'm going to try to show that in my drawing. Okay, so it looks something like this. I still have x right here along the side going up and down, and the short side down here is 10. Now our rule is that we still have our two triangles being similar. So now it's just a game of matching up our sides. Okay, so for example, 18 was the longer side from our bigger triangle that we drew. The longer side from our blue triangle we drew was x. So those match up. So I can write those as a ratio. 18 over x equals, well, now I match up the other ones. The short sides match up too. So we have our x and our 10. Okay, so since I started with 18 here, I'm going to start with x on top here. X over 10. Now it's just a solving problem. Okay, so we can cross multiply. Okay, so 18 times 10, 180 equals x times x squared. Okay, so now in order to solve this, remember when we have x squared, all we're going to do is take the square root of both sides. Okay, so square root. Okay, and now we got to take the square root of 180. Okay, now remember this would normally be a plus or minus. Just remember that our side length has to be positive. So I'm actually just going to write out the positive one. So 13.4 approximately. Okay, so the side length would be 13.4. Okay. Let's do one more like this before we get into the tougher ones with expressions and some quadratics in there. Okay, so you can ignore example 3. Just draw out this diagram right below. So this one's a little bit different of a setup. Okay, so we still have our diagram where we have our altitude drawn in. Okay, see that with the right angle right here. And again, this is a game where we need two side lengths filled in order to set up a ratio. Our goal is to write a proportion where we have two similar triangles where we can use that information in order to solve for the missing side. So this little guy would be one of the ones we want because we have the x and the 9. Okay, so I'm going to redraw that out. Notice the 9 is the shorter side than, in this case, our altitude going up and down. So I'm going to draw the up and down a little bit bigger, this one a little smaller. Really think redrawing the triangles is going to help you make fewer mistakes. So in this case, x is our hypotenuse right here, and then 9 is the short side. Okay. Now I need another triangle that's going to have two sides. You might be drawn to doing this triangle over here, but what we have to see is we don't have the length of our altitude going here, and we have nothing here, so we're not going to do that. Okay, we're actually going to have to use the whole thing. Okay, so we want the whole triangle, and the reason why is we know x is here, and we could find this whole length going across just by adding up 9 and 16. So that'd be 25. So if we look, the shortest side has to be the x here versus our hypotenuse. The longest side is the 25. So I'm going to try to draw that to scale. This is my short side, longer side, hypotenuse. X, 25 was the hypotenuse. Okay, so now we have enough information. We know that these are similar triangles to set up our ratios, our proportion. So if I started with x from this triangle, that was hypotenuse, from this one I'd want 25. Then for this one, 9 was my short side, where here x was my short side. Cross multiply and solve. Okay, so multiply across, x squared equals 25 times 9, 225. Okay. Square root both sides. Okay, and x equals square root of 225, that's 15. Okay, so that'd be my answer.